Welcome back to the FDP on non-destructive testing and evaluation. Our speaker for this session is Mr. Ashish. He is associated with Absolute Testing and Consultancy NDT Chandigarh as a head of technical services. He will talk on NDT case studies on various civil structures. Sir, kindly proceed.
Good afternoon, everyone. Thank you so much for inviting me for this wonderful session. So today, as ma'am told, that we are going to discuss about the various case studies and what type of challenges and what type of problems we face during the condition assessment, or we call it health monitoring of existing structures. So especially this entire session is toward the RCC structures. Those are civil structures which are in various areas. So I think my screen is visible to all of you.
Yes, it is visible.
Okay. Now, starting with some case studies, there are various type of case studies which I have included in my presentation. That one of the starting with this why the need of NDT, and you have gone through why the NDT is required in nowadays. So here I have combined this condition assessment, or we call it health monitoring of existing structures, with this sustainability also, because we all talk about this sustainable development in present day, as we know that the India is growing in infrastructure rapidly, and with the globalization and raising awareness, that structural repair and rehabilitation is also the need of our, because if we are not able to sustain our structures for at least of 100 years, then how we can say that we are doing the sustainable development? We can't talk only about these sustainable technologies, but we can it's our responsibility that we will make sure that our structure should sustain for at least of 100 years. So for the sustainability of any type of structure, the NDT plays a very important role, so that during its service life, we will make sure that the present condition of the structure is as per the design and as per the serviceable requirement. So NDT will be very helpful to getting all this data from the existing structure. So here I am talking about one of the building which was from military station Udhampur, which is in Jammu area. So what was the actual problem was that there are some cracks and spalling was observed in the structure at initial stages, and we have done the condition assessment by using this non-destructive testing and some semi-destructive techniques also. It was a G+3 structural RCC framed structure building and situated at military station Udhampur. So talking about the introduction of that structure, the structure was around 32 to 35 years old. It was located in Udhampur, as I already told you. So how we do this whole procedure, we call it structural health monitoring. Initially, we will do the detailed visual inspection so that we got to know what is the type of damage, what is the present condition, what is the extent of damage, and what is the source of damage. Because by using these non-destructive techniques, we can easily find out what is the type of damage. Type of damage mean to say whether there is a crack. If those cracks are because of some loading failure, or those cracks are because of some corrosion cracks are there, or it may be because of settlement of foundation. So based on the type of defect, we got to know what. After that, we'll find out what is the extent. For example, if we talk about the extent, there is a crack developed over a beam or column or any of the structural member. but by visually you can't tell that what is the extent of that crack, whether that crack is a surface crack or that crack is how much deep it is inside the structure. Is that is a structural defect or it is a surface crack? Because there may be chances of surface cracks because of that crack may be on the plaster surface only. So by using these techniques we can find out whether why this what is the extent of the crack. And the third and the most important is source of damage, why this type of structural cracks are or why this type of defect is happening. So an investigation was carried out to check the concrete quality, corrosion in the reinforcement bars, carbonation of concrete, and ingress of salt in concrete. These are the primary our primary objectives. Then how we have done that concrete quality was find out by using ultrasonic pulse velocity test. I think you have gone through the or you have not gone through the testing methods. So I'll explain about this method also. And the second is rebound hammer method. And carbonation depth was determined by using phenolphthalein based indicator, and we call it phenolphthalein test. So this is the, you can see this is the plan of a building. It is that column which required full length repair, which is marked with orange color, and column which required repair up to second floor, which is marked with yellow color. So we have done the condition assessment of this building, which is the whole plan is shown over there. We will discuss later about all these components. So what we have found based on the first visual inspection was done. So what was the observation? The first observation is that the exterior columns of building having a vertical cracks and spalling at some of the locations. So based on the vertical cracks, we got to know that these cracks were exactly over the line of reinforcement. So this indicates that there is a chances of corrosion inside the embedded steel reinforcement. And along with the cracks at some location, spalling was also observed. So what is this spalling? Spalling means the detachment of cover from the parent concrete due to corrosion of reinforcement is called spalling. So at some locations the spalling was observed, and based on the vertical cracks and spalling we got to know there is a problem of corrosion in the existing structure. Then dampness and efflorescence on walls was also observed, especially at the lower level of the building. Some minor cracks along with the opening of window and doors. Damaged staircase of servant quarter entrance from the backyard of the building. Spalling of concrete and exposed corroded reinforcement in exterior columns of both the buildings. Termite attack on the ground floor and first floor of the buildings. Then backside staircase along with the servant quarter of building is completely damaged. Brick tiles on the terrace of the buildings are damaged, which leads to the ingress of water through them. And plantation growth on the terrace of the building and the rainwater pipes are damaged. These were some basic visual inspection points which we have mentioned. And now I'll show you some images. Before that images, I will explain how this visual inspection of RCC building gives you the define the condition of what type of reaction is there, or it is a chemical reaction or it is a physical reaction. So visual inspection of RCC building shows if there is an efflorescence, then leaching was observed. It means that if there is a salt present in your concrete, or it may be present in your plaster, or it may be present in the bricks. So due to fluorescence, whenever there is an ingress of moisture, the salt present into the structure leaches out in forms of carbonic acid and calcium hydroxide developed by the hydration of Portland cement. If it is in the reaction with the cement, so it is a chemical process. Then second is permeable and unsound concrete. here I talking about the permeable and unsound concrete means that your concrete is not of good quality. It is permeable means the water or moisture can ingress through it easily, and it's a non-acidic reaction between calcium components of hardened cement paste and components of aggressive liquid. This type of problem generally happens at in industrial buildings where these type of aggressive liquids are used. Then cracks and gradual disintegration of concrete. If there is a cracks and gradual disintegration of concrete is observed, which may be because of the sulfate attack. That sulfate may comes from the water which are used, and this is again is a chemical reaction. That sulfate attack as well as the alkali aggregate reaction, this is because of the presence of the sulfate and alkali aggregate reaction, there is a chances of expansion of your concrete. So because of this expansion, the cracks develop, and again this is a chemical process. But in alkali aggregate reaction, what you will observe a chalky surface around the aggregate particles. And then raveling and disintegration of concrete, that reaction of hardened paste with acidic water. In case there is your concrete is in contact with some acidic water, this type of defect will occur. Again, this is a chemical process. Now coming to the spalling of concrete, we have as I already told you what is spalling. Spalling means the disintegration of your cover from its parent concrete. So in that case, crystallization of penetrated salt solution generate excessive pressure, or you can call it develops an internal pressure, and this is a physical process. And because of this change in dimension, the crack develops initially, and which leads to the spalling of concrete. Then second is cracking. Cracking, there are several reasons why this type of cracking can be occur. So which one of the reason is shrinkage and unequal thermal expansion, then that is a mechanical action. And the last one, which is the most important, and which was observed in this building in this case, that rust, staining, cracking, delamination and spalling, which is because of the corrosion of steel, and that is an electrochemical process. So corrosion of steel is the main reason behind the whole problem, because this corroded reinforcement, what happens when the reinforcement gets corrosion, the rust starts depositing over the steel, and the size of the particular steel increases. As the size of that steel reinforcement increases because of the deposition of rust, the internal pressure starts developing, and that internal pressure will exert pressure towards the cover side, and initially the crack will develop, and which leads to the disintegration of cover from its parent concrete, which you can see here. This is the cracks in columns. This is because of reinforcement is getting corroded inside, and this is the initial stage. You can see this is the vertical cracks on the column which we have seen, and this is the second condition when spalling occur. This is, you can see, this is the spalling of concrete, and here you can see the steel is getting corroded, and because of this corrosion, this spalling occurs. So here in the visual inspection, as we have written over there, that was a damaged staircase, again spalling of concrete. So after this visual inspection and the all these things, we will decide what types of non-destructive tests we are going to conduct, or there maybe we will conduct some other semi-destructive test also. Why I'm calling it semi-destructive? Because we have to take out some concrete sample also, so that we will find out the presence of salt or any type of carbonation is there or not. So a number of non-destructive and partially destructive, or call it semi-destructive techniques for the assessment of concrete structure, and also to predict the cause of deterioration of the existing structure are available. So we have classified the NDT in 4 groups. Like first and very important is the strength test. Here we find out what is the present grade of concrete, or we can call it present strength of concrete. Second is your durability test. Durability in terms of density of concrete, how dense is concrete, whether there is a development of cracks or not, whether your concrete is homogeneous or not. This type of test is comes under the durability test. Then performance test and integrity test and chemical test. Performance test means that how your structure is performing in such condition. Is there is any deflection, or is there is any strain over your structure, or there is some identical cracks or spalling or that type of what is the current performance of the structure. Then the chemical test, and we will collect some samples and we will do some chemical tests over the sample. So with the help of these tests, we can find out in situ strength, quality of the concrete, to precise identify the damage and cause of the deterioration of the structure. So what are those tests? The first, and starting with the Schmidt hammer test, or we call it rebound hammer also. Second is ultrasonic pulse velocity. Third is your carbonation test, and fourth is your concrete resistivity test, then reinforcement scanning test, and chloride sulfate ingress test. These are the 6 tests we are going to we have done, and we have performed over this structure. So what is this Schmidt hammer test, or we can call it rebound hammer test? This is the fastest method to evaluate the quality of concrete based on the hardness, which is indicated by rebound number. So what is the basic principle of rebound hammer? It works on the principle of hardness of concrete. By using rebound number, we can estimate the compressive strength, but not exactly, because rebound hammer gives you basis on the hardness, surface hardness of the concrete. So there are certain parameters which are going to affect the hardness of the concrete. So it is important to mention what is the present condition, what is the hardness of concrete. And in such cases where the concrete structure is quite old, you have to take out some core samples, and based on that core sample, you will calibrate your rebound hammer over the core samples, and you will develop a calibration graph on a particular structure. Only after the development of your particular graph, you are able to estimate the correct compressive strength of a particular structure. So if the strength of the concrete is high, the rebound number is also high. That is the basic principle. For this test, when the plunger of rebound hammer is pressed against the surface of concrete, the spring controlled mass rebound and the extent of each rebound depends on the surface hardness of the concrete. As I told you, that it completely depends on the surface hardness of the concrete. So the surface hardness of the concrete, and therefore the rebound number is taken to be related to the compressive strength of the concrete. So in the latest rebound hammer, there is no need of angle correction. So why I have written this? Because initially there was a mechanical type rebound hammer. In that rebound hammer, you have to mention what is the angle you are using. Generally there are 3 cases arise, that you are using your rebound hammer horizontally over the vertical surfaces. You are using your rebound hammer vertically downward over the slab or foundation or any type of structure. Or the third case arises when you are using your rebound vertically upward over the roof slab. So these 3 type of cases arise, and initially when there was a mechanical rebound hammer were used, that you have to apply a angle correction And based on the use of your rebound number, the calibration graph is different for different type of application. But by using the latest rebound hammer, which is digital rebound hammer, there is a gyroscope is installed in that rebound hammer, where angle correction is not required. So this is how you can give the quality of concrete based on the rebound number. So if you are getting the rebound number greater than 40, it means that is a very good and hard layer. 30 to 40 ranges the good layer. 20 to 30 is fair. Less than 20 is poor concrete. And if it is coming 0, which means it is delaminated. It means that there is a gap between the parent concrete and the cover of the concrete. That's why there is no value is coming out. So this is the latest rebound hammer. You can see that is a completely digital rebound hammer, and it is the make of the rebound hammer which we are using is Prosec Schmidt rebound hammer, which is N-type rebound hammer. There are 3 types of rebound hammer are used in civil engineering, or you can call it for the evaluation of the concrete structures. One is N-type rebound hammer. The N-type rebound hammer is used where the maximum nominal aggregate size is up to 20 mm. And there is another rebound hammer which is known as P-type rebound hammer, which is a pendulum type rebound hammer that is used to determine the compressive strength of less than 10 Newton per mm square, and that is used for in some cases we can use for the brick masonry structures also, or to find out the strength of plaster. But here that which is shown over here, it can be used up to the strength of 80 Newton per mm square easily. Now coming, the initial was the rebound hammer test, which means based on the hardness we got the estimation of compressive strength. Now coming to the ultrasonic pulse velocity test. Ultrasonic pulse velocity test is generally used to measure the concrete uniformity, determination of cracking and honeycombing, and assessment of concrete deterioration. The principle of this test involves sending electroacoustic pulse through a concrete path and measuring the transit time taken for a known distance. So as we know that the wave propagation is involved over here, the wave propagate faster in denser medium. If your concrete is well compacted, if your concrete is well dense, and your concrete is free from any type of defects, like if there is a crack over there, then you will get low value. If there is a honeycombing over there, you will get low value. So there are certain parameters defined by IS code. So initially there was code which names as IS 13311 part 1 and part 2. IS 13311 part 1 is for ultrasonic pulse velocity test, and IS 13311 part 2 is for rebound hammer test, 1992. But recently in 2019 there is a new code, new IS code has been revised. But here for the very first time there is the change in the name of the code. Now it comes under the IS 516 part 5 section 1 and section 2. The revised code is IS 516 part 5 section 1 for ultrasonic pulse velocity, and section 2 is for rebound hammer test. So here you can see there is the based on the IS code, these are the parameters which is shown over here. Greater than 4 km per second, very good, that is the excellent quality of concrete. And 3.5 to 4 is very good concrete. 3 to 3.5 is a medium type of concrete, and below 3 it is poor or loss of integration, or we can call it poor doubtful concrete. But with the new code, all these parameters have been changed. What are the new code's parameter? It says if it is below 3 km per second, that is poor quality. And if the second range is 3 to 3.75, if the value is coming 3 to 3.75, which comes under the doubtful range. Below 3 is completely poor. 3 to 3.75 is doubtful. 3.75 to 4.4 is your good, and above 4.4 is your excellent. So these are here you can see this is the ultrasonic pulse velocity equipment over here. So I'll show you another slide where there is a comparison between both the IS codes. Just give me a second. I'll show you. I have not involved that one in this slide, so I just got to these are the different types of yeah, you can see here this is the IS 516 part 5 2019 latest code. Here you can see above 4.4 it is excellent quality, 3.75 to 4.40 is good quality, 3 to 3.75 is your doubtful, and below 3 it is poor. And in case of doubtful quality, it may be necessary to carry out further test. And initially, what was the condition? This is the condition of your previous code. So above 4.5 it was excellent, 3.5 to 4.5 is good, 3 to 3.5 is medium, and below 3 is poor. At that time there was a clause of medium, but in new code there is a no clause for the medium quality, there is a doubtful. So I think now you understand this. Coming to our basic. Now after this conducting ultrasonic pulse velocity test, we got to know what is the present quality of the concrete. So what is the method how we can do the test by using ultrasonic pulse velocity? There are two probes are there, you can see in this image. There are two probes are there, one act as a sender, one act as a receiver. You can see there are two probes, one act as a sender, one act as a receiver. And by using these probes we got the value which may be suppose we got the value of 2500 meter per second. It means your quality is your concrete is poor quality. So and these transducer have a specific range as per the IS code. The frequency of this transducer should be in the range of 40 to 60 kilohertz. So generally the manufacturer provide with the 54 kilohertz transducer, and there are three methods of conducting ultrasonic pulse velocity on the RCC structure. One is your direct transmission. In direct transmission, both the probes are placed directly opposite to each other. In case of like your columns, you can test directly. In case of footings where the both you are not able to place the transducer opposite to each other, then you have to place the transducer perpendicular to each other, which is called semi-direct transmission method. And the third one is in case of slab where both these methods are not possible, then you have to place both the transducer on the same plane. That method is known as indirect transmission. So coming to the carbonation test, what is the carbonation test? Carbonation is nothing but it is the process in which pH of concrete decreases toward the acidic side, and the concrete which is fresh in nature as highly alkaline in nature. So concrete is having micropores, and these pores are filled with liquid having pH value as high as 12.5. Thus the concrete is alkaline in nature. Carbonation of the concrete is the reaction of CaOH2 with the atmospheric carbon dioxide and its conversion into CaCO3. So because of this reaction, your concrete starts behavior, your concrete's nature changes from alkaline toward the acidic. So because of this acidic nature, your pH of concrete may decrease to 5 to 6. But the moment your pH of concrete's reduced up to 8.5, uh, it is the alarming stage. So the outer zone of concrete is affected first. Due to the passage of time, carbonation proceeds deeper into the mass as CO2 diffuses inward from the surface. If the carbonation depth equal to the cover of the concrete, then your steel is prone to corrosion damage. That's why if you see, the cover plays a very important role in terms of durability of the concrete. So by this test, we measure the carbonation depth of the concrete. To determine the path of the carbonation, drilling a hole is also done in stages, and the phenolphthalein solution sprayed over every stage. As soon as the color of the concrete becomes pink, stop drilling and the depth of the hole is measured. So this is the other method to find out the carbonation depth if we are not going to take out the core samples. So we can go with the drilling method. But here we can do the core direct spraying the phenolphthalein over your core samples. And concrete is alkaline in nature. As I already told you, the pH of concrete at the time of construction is around 12.5. During the course of time, carbon dioxide from the external environment enters into the concrete, and because of the chemical reaction of carbon dioxide and calcium carbonate, the alkaline environment changes to the acidic. So this is the necessary condition for the corrosion. So because of this acidic environment and presence of moisture, which becomes the most favorable condition for the corrosion of the embedded reinforcement. So this change can be detected by phenolphthalein test. The change in the color of the phenolphthalein take place as pH of value changes from 12.5 toward the lower pH. Rainbow indicator is the name of the chemical which is available in the market. Here you can see there are two types of chemicals are available in the market. One is the rainbow indicator and second is the phenolphthalein indicator. In rainbow indicator, it gives exactly the what is the color. Based on the color, you can tell what is the present pH of the concrete. But the simple phenolphthalein indicator only tells you whether your concrete is carbonated or your carbonation is there or it is non-carbonated. Because if it is carbonated, it will be of colorless, and if it is non-carbonated, it gives a pinkish color in phenolphthalein indicator. But if you are using rainbow indicator, then you can get this color band and you can match this with given color band what type of color you have achieved, and you can easily tell what is the pH of existing concrete. So here you can see we have taken out the core sample and we are measuring the core depth. So here you can see that the area which is of pinkish color, it means it is non-carbonated area, and the area from the starting of the core toward the around, it is around 40 mm. It shows that this area is carbonated. So it means that ingress of carbonation starts from outside and slowly it penetrates into the concrete surface. Here again, the rate of carbonation also depends on the density of concrete, or you can call it quality of your concrete. If your quality of concrete is good, the rate of carbonation is always low. Here you can see this is the another example of this carbonation core sample. So this type of chemical is available in the market. This is the example of rainbow indicator. So then after that, we conduct reinforcement scanning test, or we can call it ferro scanning. So ferro scanning is a device which is used to locate reinforcement bars and estimate the diameter and depth of the cover. So where we have to use this type of instrument, where we are not aware of the drawings, or the drawings are not available with the department or client. So we have to find out what is the reinforcement provided, what is the size of the reinforcement, what is the cover, what is the center to center distance between the reinforcement bars. So this device is based on the interaction between the bars and low frequency electromagnetic fields. The physical principle that is employed in the electromagnetic induction, whereby the alternating magnetic field induced and electrical potential is an electrical circle intersect by the field. Whether there is an interaction of this field, it gives the some beep kind of sound, and it gives you that there is a reinforcement embedded, or there is some ferrous material is embedded into your concrete. So the test for the reinforcement scanning is done with the help of, the name of the instrument is Hilti PS200. The advanced version is also there, which is Hilti PS250 ferro scanner, and a portable system for detecting rebar in concrete structures. The tools help in obtaining real image of the reinforcement and evaluate the reinforcement mesh. Hilti PS200 ferroscan can record the depth and position of rebar over long stretches and obtain average coverage and statistics. So it comes with the software which scan the area of 600 by 600 mm, and in this 600 by 600 mm you can find out, you can get the real-time image, what is the condition of your reinforcement, what is the size of the reinforcement, what is the distance between the reinforcement, and what is the cover of the reinforcement. So this tool consists of image scanner that records the data, then the recorded data is transferred to the monitor for the further investigation. The major analysis and conclusion is done on the computer on the analysis software to produce report of the data recorded, which is further submitted to the structural consultant for the preparation of the structural drawings, and there is a establishing the stability of the structure. It means we are doing a reverse engineering. After constructing, we are finding the what is the reinforcement provided in the structure. Based on the data available, we will prepare the structural drawings. The limitation of this test are the interference may occur in images due to scraps of reinforcement in concrete, tie bars, other rebar cross aggregates with ferromagnetic properties, because it completely works on the ferromagnetic induction. So if there is any type of ferrous material is embedded into your concrete structure, then in that case it will give some erratic or there is some interference in the image. So this is the scanner, and this is the PS200 monitor. You can see this is how this 600 by 600 mm sheet is scanned. It will be scanned in a way that 4 times from x-axis and then 4 times on your y-axis. Then the complete image is obtained by scanning in this method. Here you can see there is a we are scanning the beam from bottom, so that we got the bottom reinforcement. Then coming to the concrete resistivity test, this is also one of the most important tests. It gives you the likelihood of corrosion. So surface resistivity meter provides very useful information about the surface of the concrete. It is not only provide the corrosion information, but also provide the correlation between the resistivity and chloride diffusion rate. So what is the operating principle? It works on the Venner probe. The recipod is designed to measure the electrical resistivity of the concrete. A current is applied in 2 outer probes, and the potential difference is measured between the 2 inner probes. The current is carried by ions in the pore liquid. The calculated resistivity depends on the spacing of the probes. So resistivity is defined in that way, kilo ohm centimeter. So this is the table which gives you what is the possible corrosion rate, with whether the value is getting higher, less equal to higher or equal to 100 kilo ohm centimeter. It means negligible risk of corrosion. If it is 50 to 100 kilo ohm centimeter, that means the low risk of corrosion. If it is 10 to 50 kilo ohm centimeter, that is moderate risk of corrosion. And if it is less than equal to 10 kilo ohm centimeter, high risk of corrosion. Here you can see the image of resistivity meter, that 2 outer probes are there and 2 inner probes are there. So that the current is applied from the 2 outer probes, and the 2 inner probes will measure the potential difference. And by this method, we can find out the resistivity of that particular concrete, which is in kilo ohm centimeter. So then chloride and sulfate ingress test is done. This test is done in the laboratory. It is not a in situ test. For this, we have to collect some samples, and the sample is again collected with the core which you have collected. So quantity of chlorides and sulfate in the concrete is generally determined chemically. Sulfate and chloride contents of concrete samples collected from various locations were found out. The permissible limit of chloride contents of weight of cement is 0.6%, and in some cases we have seen that 0.15% is enough for the onset of corrosion. But this is the actual codal provision that 0.6% is permissible limit, and for sulfate it is 4% by weight of cement. So what is the, if we get required cover thickness and good quality, it means that we have measured the cover thickness and we are getting good quality by using ultrasonic pulse velocity test. It means there is no chance of corrosion, or you can call it there is no corrosion prone structure. Then required cover thickness, bad concrete quality, which leads to the corrosion prone, and very less cover thickness yet good quality over concrete, again which is corrosion prone, because as I told you that the depth of your cover plays a very important role in showing that whether your concrete is corrosion prone or not. So this is the NDT analysis. You can see these are the C1, C2, C3 are the locations which I have initially shown the plan, where you can see these are the location. We got the rebound hammer value. Based on the rebound hammer, the second is your fourth row is for average rebound value. Then average ultrasonic pulse velocity value is there. We got the compressive strength. Based on the pH, we applied the correction factor, and this is the final compressive strength. Here you can see the range of compressive strength where UPV value is good and compressive strength is also getting good, but where there is a delamination, their compressive strength is also low, as well as the UPV results are also low. So these are the test results of rebound hammer and ultrasonic pulse velocity. These are the test results of resistivity, where you can see it is in the range of 38 to 15.82, which indicates that there is a moderate risk of corrosion. And these are the test results for sulfate and chloride ingress. You can see at the chloride, at some locations the chloride is at the higher side because of these chlorides present, which is in form of salt, which are responsible for the acidic environment also. So what is the repair? Now coming to the repair of the structure, we have done the repair of the structure based on the NDT results and based on the visual observation. We find out there are major defects. One is the cracking, which is because of the corrosion of reinforcement. Then rusting of bars. The bars, reinforcement bars are corroded. Then spalling of concrete, again because of the rusting. Then dampness and efflorescence. This is the dampness and efflorescence act as a catalyst for the this carbonation and rusting process. And railings were the completely damaged and it can be replaced completely. So this is how the structure can be repaired. Repair of spalling of concrete at outer columns, where we have to, first of all, we have to support the structure by using scaffolding and surface preparation to be done. In surface preparation, you have to remove all the loose materials. Then we have to apply a corrosion protection to existing reinforcement. Then fixing grouting of new reinforcement, which can be done by using chemical anchorage. Then you have to, before applying the micro concrete, you have to apply a bonding agent, because there is it is difficult to make a bond between the old and new concrete. That's why we are using some epoxy bonding primer. Then this is the way we can repair the dampness and efflorescence at the ground level sunken area. Again, surface preparation, waterproofing coating, and then patch repair with the mortar. And repair of the thin hairline cracks in the brick wall. Again, that is, if it is a we have to make a 3 mm wide and 3 mm deep V groove the cutout, will apply non-rust shrink repair mortar and apply water resistant white cement for the finishing. So this is the way how we can do in a general way I'm telling you, but for this it is a completely different science how these materials are chosen, how these material are how much effective, that can be defined in some other topic, which is completely on the repair and rehabilitation of the structures. So this is how injection grouting is done. Injection grouting is done by packer drilling, which we called it nozzles, then grouting of the gap, then surface preparation is done, then drilling of holes are done, then the holes will be cleaned by pressure air, and after that we'll inject the epoxy grouting in this soap. So this is the conclusion, that observing the damage condition of the outer columns, 12 columns were marked in orange color, which I have shown in the plan initially, requires full height repair, and 11 columns marked with yellow color in the plan requires repair jacketing up to second floor only. And exposed concrete was found to be carbonated. The carbonated concrete should be provided with anti-carbonation coating if the spalling of concrete has not started, so that the rate of carbonation should be decreased. Due to the effect of corrosion, the spalling was observed in these columns, so it is necessary to repair the structure so it will be unable to withstand against the combination of load for which it is designed. The spalling concrete from column should be repaired with micro concrete. All the repair work required to be done used to be carried out as per the methodology sequence provided above. And here you can't use normal concrete, you have to repair your concrete with micro concrete only. And after this repair and rehabilitation, again we will conduct the non-destructive testing, especially your ultrasonic pulse velocity, so that you got to know that after repair what is the outcome of that repair, whether that repair is done perfectly or not, which can be again accessed by the non-destructive testing, which I have explained earlier. So this was the one case study of building. Now another case study is, this is the case study of pre-stress bridge over Ashwani Khad on Kufri Chal Kandaghat Road at RD 45 by 100. It is near to Chandigarh. It is toward, when we go toward the Chal, there is a place in, you might be heard about the Chal Palace. So toward that road, there is a place called Ashwani. There is a river, or you can call it a small river, which is called Ashwani Khad. So pre-stress bridge, which was 35 meter span over the Ashwani Khad on Kufri Chal Kandaghat Road at RD 45 by 100, is under construction by Himachal Pradesh Public Works Department. So the design of the structure was in that way that 3 main girders have been casted. In the middle girder, due to breakdown of concrete pump, work remains suspended for 4 hours, due to which crack developed at bottom flange diagonally in a length of 3 meter at the time of initial stressing. Why this happened? Because whenever there is a concreting, the concreting should be done in a continuous manner. If there comes any type of lag or the work is suspended for 4 to 5 hours, there is the chances of formation of cold joint. So exactly this happens over there, and after the stressing of first stage, the diagonal cracks were developed. So how we can do what we have to do over there, then we design and scope was filling the crack with high strength low viscous epoxy grout, and the ultrasonic pulse velocity tests were conducted before and after the repair of the girder, so that we will compare what is the condition of the girder before the repair and what is the condition of the girder after repair. So these are the cracks over the girder. You can see this type of crack was developed. So these cracks were sealed by using grouting material, and then injection grouting was done over the surface. This is how the nozzles were fixed in a interval of 150 mm center to center. So these are the result. You can see downstream side of the middle girder, UPV before treatment, UPV after treatment. Ultrasonic pulse velocity, initially you can see it was not more than 3100. The maximum value we are getting was 3157. But after the injection grouting, you can see all the values are in the range of excellent or very good. So here the quality of your concrete is uh, improved by injection grouting. But this injection grouting can be that how you can ascertain that your concrete is improved by using non-destructive testing, where we can use ultrasonic pulse velocity technique. So what was the conclusion? The average relative strength of the concrete varies from 40 to 47 Newton per mm square, corresponding to rebound hammer test. We also conducted the rebound hammer so that we will be assured that the required grade of concrete is also not disturbed because of this problem. The required grade was 40 Newton per mm square, and we were getting 42 to 47 Newton per mm square. The general quality of concrete is improved after epoxy treatment in the range of very good to excellent. Since after the treatment, the quality of concrete is very good, it shows the absence of corrosion, honeycombing, cracks, voids, etc. at the location where the tests were conducted. So it means that by using this technique, you can ascertain that your structure is improved. So now there is one very interesting condition which I have gone through this problem, that during construction of garage shed, there was a gap left between the pedestal and plinth beam. This is because of the negligence of site engineers. You can see this type of gaps were observed. You can see that is the bottom is the foundation. From foundation, the lower portion, this portion is called pedestal, and pedestal and plinth beam, between the pedestal and plinth beam, you can see there is a gap between. So technically the your structure is resting on the uh, reinforcement bars only, there is no concrete is there. So we find out this type of problem, and now it was a challenge to how to fill this gap, because it is very difficult to place any of the material, and you have to make sure that the load transfer can be done easily with the material which you are going to place over there. So what is the repair methodology we have done? The size of the column from the foundation was enlarged by using micro concrete by jacketing. Shear connectors were provided of 8 mm at the distance of 350 mm center to center in a staggered formation up to plinth beam. The thickness of the jacketing of the micro concrete is 75 mm. The jacketing is should be done from top of the foundation level to the top of the plinth beam level. And extra reinforcement of 10 mm is also provided by chemical anchorage into the foundation. Jacketing is done up to the top of the plinth beam. So again, the same procedure we have followed, repairing of the how we can do supporting, scaffolding, surface preparation, fixing, grouting of new reinforcement, epoxy, bonding primer, and this is jacketing with micro concrete. Here you can see we have excavated the whole area. Then new reinforcement bars were installed by chemical anchorage, and the size of the pedestal has been increased by 75 mm by using micro concrete. This is how the it was filled in one continuous process. This is the final result. Now here is the challenge, how you can ascertain that this concrete is filled completely in that area. Here again non-destructive testing was done. So what we have to do, we have to place one probe on the upper face of your structure, and other probe is placed on the other side, and we will find out the values of your wave propagation, whether it is comes under the range of required grade or not. So here we were getting the repair. What was the conclusion? The repair work carried out at the site is as per the specification and methodology given for the strengthening of the pedestal. Jacketing is done from the top of the foundation level to the top of the plinth beam. The bond between old and new concrete is intact. Jacketing is acting as a monolithic structure, and the average relative strength of micro concrete jacketing varies from 30 to 46 Newton per mm square. And the rebound hammer test and ultrasonic pulse velocity test after 14 days. The general quality of concrete is in the range of excellent. It means that whatever the repair rehabilitation we have done is up to the mark and the structure is safe. So there is another example which is of Ambuja Cement Limited, Darlaghat. Here what we have done is it is a example of corrosion over there. How this their images are there. You can see this is the spalling of concrete. This type of problem we face where there is a problem in your slab, and you will see that reinforcement bars are completely exposed. So here we have to choose the testing uh, 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 for the to check the what is the rate of carbonation, if and the chemical analysis plays a very important role in such type of structure. Then this is how the whole loose concrete is removed, and then this is the method how the rust remover was applied over your steel reinforcement, because your existing steel is completely rusted. To remove the rust from your steel reinforcement, there is a chemicals are available. Here we have used ferrowet rust remover, or there is another chemical which is named as rust of 100, which is available in the market. So by using this chemical we remove the rust. Then this is how the rust remover is applied. Then new reinforcement bars were placed, and by drilling the holes by using chemical anchorage, and uh, you can see the extra reinforcement is tied with the existing reinforcement, and shear connectors were also used. After that we will apply the rust protection inhibitors, that is a rust remover come inhibitors, which will protect the reinforcement from getting further corrosion. This is anti-corrosive coating. After that, we will apply a bonding primer. Why this bonding primer? As I told you, that is the bond between old and new concrete will not be formed by normal without any type of bonding agent. Here we have used Nitobond AR, and this is how the polymer modified mortar is used. Here you can't use normal concrete or normal mortar. Uh, uh, we have to use the polymer modified mortar, or we can use the micro concrete. So this is before and after image, you can see. Again, then the cracks were also there. We have sealed these crack by this method. You can see we have sealing the crack, and the nozzles were fixed. From these nozzles we will inject the low viscous high strength epoxy grout. So this is how the putty was filled over there. And after this whole work of repair and rehabilitation, again the whole procedure for the non-destructive testing can be done to evaluate the structure, or you can ascertain that your structure is now safe or not. So the last is there is a condition assessment of check the structural integrity of fire hazardous factory, because nowadays we have seen, or you can heard about, there is a lot of fire incident happening nowadays. So it is a one of the example of Medipol Pharmaceutical India Private Limited in Baddi district, Solan, Himachal Pradesh. So what we have done, survey was carried out to assess the integrity of the fire affected portion of the factory by the team of our company. The concrete strength and quality was found out by using the same ultrasonic pulse velocity rebound hammer test method. Core samples were taken out from various structural members to check the internal strength and quality of the concrete member. The visual inspection was carried out to find out the locate the dampness, cracks, and other defect in the building. Now coming to the fire damage building. In fire damage building, it is very important to take out the core samples. By using only NDT, it is not possible to determine the condition, because the effect of fire will start from the surface and will it start affecting your structural member inside the concrete. So as we know that once a fire starts and the contents and the material in the building are burning, the fire spreads via radiation, convection, and conduction, with flames reaching temperature between 600 to 1200 degrees Celsius. Harm is caused by the combination of effect of smoke and gases which are emitted from burning materials. So what type of material is inside the building, and how much heat is generated, and how much smoke and gases are evolved because of this, plays a very important role. Concrete, as we know, concrete does not burn. It cannot be set on fire like other materials in a building, and it does not emit any toxic fumes when affected by fire. So it will also not produce smoke or drip like a molten particles, unlike some plastic or metals. So it does not add to the fire load. For these reasons, concrete is set to a high degree of fire resistance, and in the majority of applications, concrete can be described as virtually fireproof because it doesn't set on fire. So it in this the slow rate of heat transfer that enables concrete to act as an effective fire shield, not only between adjacent spaces but also to protect itself from fire damage. The rate of increase of temperature through the cross section of concrete element is relatively slow, and so internal zones do not reach the same high temperature as the surface exposed to flames. It means that the outer of the structure, RCC structure, the outer temperature of the RCC structure is quite high, and if you go toward the inside, it is quite very different from your outer surface. Standard ISO 834 or BS 476 fire test on 160 wide into 300 deep concrete beams shows that after 1 hour of exposure on these sites with a temperature of 600 degrees Celsius is reached at 16 from the surface, this value halves at just 300 degrees at 42 from the surface. It means that as compared to outer, the inner surface of the structure or RCC is quite very cool. A temperature gradient of 300 degrees is about an inch of concrete. It means within the inch of concrete, when we goes from outer to inside, there is a decreased temperature gradient of 300 degrees. Even after a prolonged period, the internal temperature of the concrete remains relatively low. This enables it to retain structural capacity and fire shielding properties of separating elements. So the surface appearance of the structural members gives an idea on the extent of heat to which these members might have been subjected to during the fire. So whenever we are going for the structural or condition assessment of these type of fire damage structure, first of all, we have to find out the history behind the whole thing, that what type of material was there, what was the duration of the fire, what is, then after that we will take out the physical condition. We will get the information about the physical condition, whether that surface is what is the condition of surface, and these information is very vital for assessing the appropriate damage classifications and planning the repair techniques. It is, however, to be kept in view that these are the subjective observations, and results would be dependent on the experience and skill of the person carrying out the investigation. In spite of these drawbacks, these information is necessary, and when examined with the information received from other methods, provide a valuable tool taking decision on type of repair to be carried out. So what generally happens? First of all, we will find out what is the condition of plaster and finish. So if there is the reinforced concrete structural members are either kept exposed or rendered with cement mortar. Generally, we apply the plaster over their structure with the ratio of 1/3 or 1/4, and these members would have been cladded with other material also, which is wood, marble, aluminium, puff panel. Any type of material can be used for the appearance point of view. The condition of these finishes is categorized and recorded into 5 groups. One is unaffected, second is peeling, third is substantial loss, total loss, and destroyed. So this is for the external plaster condition. We are divided into 5 groups. Then color. The color of the concrete may change as a result of heat due to fire, maybe, and may give an idea of maximum temperature attained. The correlation between the decoloration due to fire and a possible temperature attained is available in technical report number 33, assessment of repair and concrete structure by Concrete Society UK. So due to fire discoloration take place, the possible change in concrete is normal pinkish, whitish, gray, and puff. Then there is another chances which is called crazing, the development of fine cracks on the surface of the concrete due to sudden cooling of surface with the water is termed as crazing. Whenever there is a fire and you have to call the fire brigade, at that time, whenever the water falls on the surface of your structure, these grazing cracks develop due to the sudden cooling of the surface. So these fine cracks are restricted to surface layers, and no structural significance of material has been accounted for. But you have to make sure that whether these are the grazing cracks or these are the structural cracks. To find out that, you have to conduct the non-destructive testing. Ultrasonic pulse velocity gives you the value of whether these cracks are deep into the structure or these are the surface cracks only. Then spalling of concrete due to the deterioration. Spalling is the deterioration process, as I told you in my previous slide, that in which what happens, that your concrete portion, which is called cover, has separated and fallen out from the parent concrete member. Due to spalling, the reinforcement gets exposed. Composite action between concrete and steel reinforcement is reduced. The spalling seriously affects the strength, stiffness, and durability of the member. 5 types of spalling considered: unaffected, minor, localized to corner, considerable to corners, and all surface spalled. Then exposure condition of reinforcement correlation is there. Then how much is your condition is reinforcement is that is called that exposure as 25, 50, or more than 50%, which with the indication of buckling condition of main reinforcement. Then cracks is there due to heat. You can see by visual inspection, you can find out whether there are some structural cracks or not. Then distortion, the extent of distortion of the structural member affected by fire in the form of deformation, deflection, twisting, etc. And delamination of concrete, it is the process in which concrete layer is delaminated from concrete but not fallen from its parent concrete. So this is known as delamination of your concrete. So how you can find out whether this delamination is there? By using a hammer, or by using a clear hammer, you can find out the hollowness sound, which indicates that there is a delamination of concrete. Here you can see we are testing the rebound hammer test over the beam and slab of the building. Even during the rebound hammer test, we got to know whether there is a delamination or the concrete is sound, or what is the condition of the structure. Here we are conducting ultrasonic pulse velocity test. In beam, that is, we are doing the direct transmission. In slab, we are conducting indirect transmission. This is the core extraction from the column, how the core is extracted from the column. Here you can see there is the appearance, there is a very different type of appearance of the over the column. It is this appearance because the column was covered with the puff panels, and due to fire and heat, this puff sticks to the column, which gives this type of appearance. And here we find out the core, extracted core from your column, and you can see the core is splits due to development of internal cracks, and you can see the image where the crack is developed in deep inside the structure. This is how the core sample extracted from the beam, and you can see the beam is sagged from center, and reinforcement is also exposed over there. Again, internal visible cracks, you can see there are cracks are visible from where the cores were extracted. This the core sample collapsed just after the extraction of the core. It means that the internal bonding between the concrete is damaged due to heat and fire. This is how the carbonation test on the core samples has been done, and the depth of carbonation is measured. You can see when the spalt of concrete result in exposed reinforcement bar in the beams. Sagging of beam was observed. So what was the result? After conducting NDT, the concrete strength of the members of all the location varies from 5.21 to 26.60 Newton per mm square. The UP value shows that the concrete quality is in the range of doubtful at all the locations. The compressive strength of core varies from 2.63 to 15.18 Newton per mm square. The roof slab of the second floor is observed to be sagged. Due to heat, the center columns of grid line B are in highly distressed condition. The beam A2, B2 is in sagged from center of the beam. The cracks were also observed in the junction of beam and columns. So these are the from my end. And now you all are open for the questions. If you have any doubt, any type of question you want to ask, you can ask, please.
Thank you very much sir, even for this informative talk. Participants can ask your question. If you have some queries, they can ask. Participants can ask queries.
Thank you, sir.
Yeah, welcome, ma'am.
Thank you for the lecture. It was quite informative and interesting.
I think there may be some because it was completely RCC structures, and most of the participants are from mechanical side, so
Yeah.
there may be some lack in that communication also.
Maybe sir, maybe sir. Thank
Sir, are you hearing me?
yeah.
So the question is this buckling effects and things, how it is taken care, sir? Some the fired building it was told, no?
Yeah, can you, sir, please repeat? Actually, I'm not. Your voice is not clear.
The fired building,
Yeah, fire.
a building which was tested after fire, no, sir? Still not audible?
Sir, are you able to listen?
Yes sir, yes sir.
So can you please tell me
Ma'am, you
what
can
she's
raise the
asking?
question in the chat.
Fired building.
Yeah.
Asking about fired building.
Yeah, what is your question about fired building?
How buckling is taken care.
Yeah, for if there is a buckling, then you have to first of all you have to support the structure by some kind of jacks and all that, and then the complete change in the reinforcement have to be done. You have to it depends on the how much buckling is there. You can't control the buckling because there is a fire over there, and at that time you can't do anything. But after the damage, you can access the damage, what is the extent of damage, and after that you have to decide what is the extent of buckling over there. If the buckling is within the permissible limit, then you can go with the simple jacketing, and if the buckling is quite higher side, then you have to support the structure by using some jacks and props over there, and after that you have to recast the structure or column by using this chemical anchorage with new reinforcement, and then jacketing with micro concrete.
Next question. It is possible to check life of structure by NDT.
Pardon, sir?
Next question. It is possible to check life of structure by NDT.
You can't say that life of structure, but we can tell you the present grade of concrete, present strength of concrete, and what is the your structure is as per the drawing or as per the present requirement or not. Just like we have done a condition assessment of your Gulmarg Gondola in, I think, in 2017. So what we do, we have done these non-destructive testing, and then whatever result we get, we will compare those results with the actual drawings. What are the actual requirement? Suppose we have the requirement of concrete grade of M40, and we check with the non-destructive testing results that whether we are getting M40 or not, or whatever the required grade. Then if it is not, if you are not getting the required grade, it means there is some problem in your structure. We have to repair that structure, and not only from this is just only one point which is I'm telling you from strength point of view, there are certain parameters, like strength is one parameter, as I told you. Then there is another parameter, which is quality of concrete is there. If there is some cracks development, all these things can be taken care. So another question, somebody has a question, I think.
How to convert Q value to compressive strength?
How convert Q value to compressive strength, which are getting in silver Schmidt hammer? Okay, that
Yes, sir.
silver Schmidt hammer gives a conversion graph, along with that manufacturer provides a conversion graph with that. But here what I suggest is, always go with your developed graph, not the manufacturer graph, because every structure has a different hardness, especially the old structures. If your structure is older than 5 to 10 years, it will definitely going to affect your hardness. So it is recommended by us, or even with the new code, if you go with the new code, it is clearly mentioned, by using only rebound number you can't give a compressive strength. For that you have to rely on some other test also, along with suppose we having 100 columns, you have to test 100 columns, but it is not possible to take the course from all the 100 columns. So what you have to do, you take out code from 10 to 12 columns and calibrate your rebound hammer on those cores, and you will get a rebound calibrated value from that. Based on that value, you will evaluate rest remaining 90 or 88 columns, so that your whole structure will be completed, and you are not going to disturb the whole 100 columns.
Sir, one more question.
Yeah, how to incorporate rebound value in UPV? There is option is given in your uh, UPV machine, whether you are using Pundit Lab or Pundit Lab Plus, which is mentioned uh, in your instrument over there, that you have to enter the rebound value. After entering the rebound value, you will get a cumulative result based on the rebound value as well as ultrasonic pulse velocity, and you will get the strength of, or you can call it the grade of concrete. Some bricks were shown in fired buildings. It is repaired by your team, or it was not affected by fire at all? Yes, the condition of bricks were also examined, and what if that because due to heat, as we all know, the bricks are already in burnt condition, so the damage over the brick is always low as compared to the concrete, because in concrete it is a structural member, and the bricks which were you have seen, those were non-structural members. Those were acting as a curtain in the structure. So based on the physical examination, and some of the bricks were also tested for this compressive strength, we didn't find that the loss of strength over there, but we have find some cracks developed in some of the areas, and those cracks were filled by grouting those cracks, and that was repaired.
Yeah, no one is there, sir. One more question, sir. Pedialyte dampers and
Pidilite dampness and hardening solution is available. Sir, there are lots of chemicals are available in the market. I can't exactly give you the name of any of the material, but yes, Pidilite dampness and hardening solution is available, definitely. But there are another chemicals are also in the market. You have to go with that in brief. That Sika is there. Force Rock is another example. BSF is the another example. Then Dr. Fixit is also there. So that depends on what type of material you want. What is in repair rehabilitation? There is no such you can call it. There is no such defined path that you in every case you can use this type of solution. For every problem, there is a different solution.
Any question?
And these type of I think these type of test, those are explained physically more easily as compared to this virtual one. So whenever we got to chance, when the condition will be fine, we can do this type of workshop also. So there we can conduct this type of or we can make a site visit also.
Yes, yes.
Thank you, sir.
Thank you very much, sir, for giving this wonderful session, sir. Thank you very much, sir. Thank you.
Okay, thank you so much.
Thank you, sir. Thank you.
Thank you, participants. Thank you so much. That's all for today. Have a great day ahead.
Okay.